Hi everyone. In this moment, I'm recording the second video that I promised that I'm going to do for you. Okay. So, this video is about the first chapter of the IGCSE paper one. Okay, in which we are going to talk about number text, sound, and images. Sorry, the first video that I made that I record is about number systems. This one is about text, sound, and images, and data storage and comprehension. Okay, so let's see text, sound, and images. Okay, so let me explain you something here. So this is the theoretical part. So if you can pause the video and read it, but I am going to try to explain to you this part a little bit clear for you, and I hope so. Okay. So let me give you an example, and I think that I told you this in class, but that is the purpose of this video. Let's suppose that you are going to write the letter A. Okay. So the computer has something that is called character set. This one. Okay. What is the character sets means? Okay, that means that the computer is going to translate what you are typing to any of these codifications, ASCII and or sorry, Unicode. Okay, Unicode. So what is the difference between them? So I'm going to show you here. Okay, the ASCII uses 7 bits, or in some cases 8 bit. Okay, so what that means that when the computer translates every single letter, every single number, is going to be translated to some characters in ASCII. And in ASCII, when we are talking about 7 bits, we are talking about that we are going to have 128 characters. But in some cases, it's going to use 8 bits. That means 256 characters. Okay. Um, ASCII uses English and basic symbols. Here you have an example. A in capital sense, the binary of the A is this one, capital sense. The binary of A in lowercase is this one. If you notice, is the same letter but with different binary code. Okay. The advantage here is that using ASCII, you are going to use less storage. Okay. And the disadvantage is that you have limited characters. Now, Unicode, that is variable. In this one, you use 8, 16, or 32 bits. So that is bigger than ASCII. So that means that talking about characters, Unicode is going to use over 143,000 characters. Unicode supports multiple languages, emojis, and special characters. Supports Arabic, Chinese, and emojis characters. Support more languages and symbols, but requires more memory in the computer. Okay, so this is an example about this. Let's suppose that the computer uses ASCII. So if you are going to write the word pie, okay, every single character is going to be decoded to ASCII in this case. Then the ASCII code is going to be converted to binary. Okay, so for that reason, here in this example, you have the age, the ASCII is 72, and the ASCII code binary or binary is this one. The I is 105, and this is the binary. Okay. Now let's continue. Um, this is what I already told you, that ASCII is limited. Unicode is for global communication. So you are going to have many, many characters for using in this part. Okay. So in this case, the computer is going to have a lot of characters. Let's part to another part that is about text. Now let's talk about sound. Okay. So in sounds, we have this. Let me show you here. Okay. Um, the computer, let me talk something different before explaining this. In this moment, I am recording my voice. So when you listen to my voice in the spectrum, okay, we can't see it, but in the spectrum, we are going to see something. Oh, okay, we are going to have something like this. This is called waves, okay, and this is the way that the sounds travels in the air, okay. The computer cannot understand this, so for this reason, those waves must be translated to a computer language. So let me show you here. Let's suppose this is the waves of my voice. Now, and this is record by my microphone. Okay. Now the microphone is connected obviously to my computer, but inside the computer we have something that is called ADC. What is this? Analog to digital converter. That means that these waves are going to be converted to this kind of digital signals. Okay? So this is something that the computer can understand. Okay? And when this part is recorded in the computer, this is the way that is going to be stored in the computer. Now, when you are going to play this sound, sorry, when you are going to play this sound using your speakers, okay, your speakers, let me delete this. And I am not the best drawer, but let's suppose this is an speaker. Tweet, tweet, tweet. Okay, so the computers do something different. The computers takes the digital signal and is going to use something that is called DAC. DAC, digital to analog converter. Okay? And now we can listen to that sound through the speakers. Okay? Now, let's continue here. Okay, those are the terms that we use talking about sounds. Okay, so let me in this moment show you something. So, what is sampling? What is sampling? Sorry, I have some technical difficulties. So, what is sampling? Okay, I'm going to give you an example here. Let's suppose that there is a car. Let's suppose this is a car and the car is moving, okay? And you want to take pictures of that car. Let's suppose this is a camera, okay? And you want to take up many pictures about the car's movement. So as much pictures you take, the quality of the images is going to be better. Let's suppose that you are doing an stop motion video. So as much drawings you have for the movements of in this moment, let's suppose a character. So let's suppose that this is the first picture of my stop motion. Then I take another picture here, and then I take another picture here. So if I do it like this, the quality of this stop motion is going to be ugly. Okay. But what if I start taking more pictures here? So that means that the stop motion is going to be better with a better quality. So that is what sample means. Okay. So the amount of pictures you take. Okay. Now, the sample rate, sorry, the sample rate is pretty similar to the previous one, just the sample. Okay. Remember that the sample is just the pictures that you take. Okay. That is the sample. Now, the sample rate is how many pictures are you going to take. So that means that if you take a lot of pictures, the quality is going to be better. Okay. So sample is just the picture. Okay. This picture, this picture, this picture, this picture, as an example. Sample rate means how many pictures you are going to have per second. Okay. Per second. And obviously, I know that I'm talking about sound, but every single mm, it's not noise, but every single sound that I'm doing in this moment, for example, my voice, every single word, every single phrase is, for example, the picture. So as much picture I am taking in this recording, the quality is going to be better. Okay, that is simple rate. Now, sample resolution bit, that means that, so we're going to talk about once again about binary. Why? Because let me show you once again the name. Sample resolution, bit depth. What here it says, the number of bits used to store each sample. So remember, this is a sample. So how many bits I am going to use for this sample? That is bit sample resolution, bit depth. Okay. So more bits allow more precise sound representation. So if I use a lot of bits in these images, and remember that the bits could be ones and zeros, so as much bits I use in this sample, the representation of the sound is going to be better. Okay. Now we have the bit rate. The bit rate is the amount of data processed per second. Okay. So let me show you. Let's suppose that we have these bits: 1 0 1 1 0 0 1 0 1 1 1 0 1 1 1 0 0 0 1 1 0. Okay, let's suppose that in 1 second I just process this amount of bits. That's okay. But what In 1 second, I process all these bits. Okay. So that is the bit rate, the amount of bits processed. Okay. I am making a drawing, but I know that you didn't see it. But let me explain you once again. So what I said was, let me see. I'm going to write once again. Let's suppose that in 1 second, 1 second, I process 100100110. Okay, that's okay. That is the amount of bits that we are processing. But what if in the same second I process more bits? 1 0 1 1 1 0 0 0 1 1 1 0 1 1 0 1. So if the amount of bits that I process in 1 second, that means that the quality of the audio is going to be better. Okay. And file size is the higher sample rates and bits depths result in a larger size. What that means, let me show you here. And I'm going to use it in this part. If I use a lot of samples, a lot of them, and in addition to these samples, I use a lot of bits, that means that our file size is going to be bigger. And obviously, the quality of the audio is going to be better. Okay, so that is the explanation of those concepts. Okay, so here is an explanation. Sample rate. A higher sample rate means more samples per second, resulting in a better approximation of the original sound. So, common sample rates. So, I told you that here when we talk about sample rate, we are talking about hertz. Okay, so I'm going to write here. Okay, so let me once again start deleting all this. So let's suppose that we are talking about 4 hertz. Okay, so we are going to talk about now 4 kilohertz. What means 4 kilohertz? That means 4,000 hertz. Okay, so that is the reason that in this example we are talking about 4 hertz, but here I am talking in hertz, sorry, and here I'm talking about 44.1 kilohertz. That means 44,100 samples per second, and that is the CD quality. Do you remember the CDs when we use long time ago for listening to music? That is the quality. Now, if we talk about 48 kilohertz, that is used in professional audio recording. And remember that 40 kilohertz, that means 48,000 hertz. Okay? So please remember that. Now, here, when we are talking about sample resolution, okay? So remember, more bits per sample, sample, sample here, okay? Samples, remember, samples are the pictures that we take or we use in a stop motion, okay? Now, here we are talking about the bits. So as much bits you are using in a sample, right? The sound levels are going to be more precise. So look at here. If we use 8 bits in sounds, that means low quality. If we use 16 bits, that means CD quality. And if we use 24 bits, that is a studio quality. Okay. So talking about levels, when you are going to use 8 bits, you are using just 2056 levels. If you are using 16 bits, you are using 65,000 and 536 levels. And if you are using 24 bits, that means that you are going to use 16.7 millions of levels. That is the reason that the sound quality is going to be better. Okay. Um, I'm not. I am not going to talk about this. Okay. So you have that information there. Okay. But I haven't seen that information in the papers. So that is the reason that you have it there, but I am not going to talk about it. Now, calculation. So, how to calculate the audio file size? So, you need the sample rate. That means how many samples do you have in a second? Okay. You need the sample resolution. That means how many bits you are using in a sample. The number of channels, okay, and the duration. When we are talking about the number of channels, that means if you are using mono audio or audio stereo. What that means? Mono means that in both speakers, let's suppose that you have two speakers, left and right. When you're talking about mono, that means that in both speakers, you're going to listen the same. When we are talking about stereo, that means that in one speaker you are going to listen something different that is being playing in the other speakers. Okay, so that means that is stereo. Let's suppose that someone playing the guitar sounds in both speakers, but something playing the piano sounds in the right speakers, and something playing flauta is in the left speaker. That means a stereo. So mono, one channel, stereo, two channels. Okay. And obviously the duration of the track or of the song in seconds. So here we have an example. Here, 44,100 hertz. Remember, that is the sample rate. Now, 16 is the sample resolution. That means that we are using 16 bits in a sample, two channels because it's stereo, and 10 seconds. That is the duration of the audio, for example. That means that we have 14 billion millions and 120 and 112,000 bits. But if you want to convert those to a different measurement, you need to make some conversions. Here is the conversions to bytes, but later in this same video, I am going to explain you what is this. Okay? How and why a computer represents images? So when we are talking about images, we have something that is called, or you need to remember that in the images, we must talk about pixels. And a pixel is just a dot, okay? So is a picture element, the smallest unit of an image, okay? The resolution is the number of pixels in an image. That means that as much pixels you are using, the quality of the image is going to be better. The color bits, color depth, that means a bit deep. What that means, let me show you. This is pixel. And let's suppose that we are doing zooming. So how many bits, how many bits do we have in this pixel? Okay, that is color color depth. Okay, and the file size is a higher resolution and a higher color depth. The file size is going to be better. Now, the bitmap is just how the image is going to be stored. Okay, so that means that you are going to use PNG files or GPIG files. Okay, okie dokie. Now, understanding the resolution and its effects. That is just sample. The images are measured in width and height. Okay, so that means that as much width and height you have, the resolution of the image is going to be higher. That means that resolution is the image quality is going to be higher. So look at this. Higher resolution means more detail but larger file size. So here, have you ever heard this? HD, higher definition, full HD, full higher definition, and 4K. So these are the resolution for those images. So if you notice as much resolution you have, the file size is going to be bigger because you are using more pixels. Let's continue with this one. Um, the color depth determines the number of colors each pixel can represent. So I told you when I show you this part, this one. So as much bits you are using, obviously the quality of the image is going to be better. So for look at this. If you are going to use 1 bit, that means that you are going to use some black and white image. If you are using 8 bits, that means that you are using 256 colors that is used for the GIF images. If you're using 16 bits, that means that you are going to use 65,536 colors. If you're using 24 bits, that means that you are using 16.7 million of colors, true colors, real colors. If you are using 32 bits, that means that you are using more than 16.7 million of colors, and that is used in the PNG files. That means that you are using 16.7 million of colors plus, that means in addition, transparency. Okay, what that means? Let's suppose that you take a picture and you want to delete your background. That is transparency. Okay. Now, the formula about how to calculate the file size resolution in an image is just the resolution multiplied by the color depth. Okay, so here we have an example. We have an image of 1920 width times 1080 of height. That is the image of the size, okay? And that image has 24 bits color diff. So what you must do is just multiply those numbers, then you have your result in bits. So later I'm going to explain you how to convert that measurement in another unit. Okay, I apologize if I am pronouncing measurement wrong. That is a word that is so hard for me. Okay, now understanding how data storage is measured. Okay, so let me explain you here. Computers store data using binary base 2. That means that the storage unit are based on power of 2, not 10. Okay, so I am going to explain you this right now using my notebook, digital notebook. Okay, so remember, computers always use binary, binary. Okay, and we as human, we use denary. This one is base 2 and this one is base 10. That is the reason that now you are going to find something new for you. Okay? I know that you haven't heard this before. So let me show you. Charan, here we have. And let me try using this. Okay. So let me explain you. If you notice on the slide on the left of the screen, we are talking about a bit. Okay, so the bit is the smallest unit of measure in a computer. Okay, then we have a something that is called nibble. That means that we are using 4 bits. What that means, if I use 0, 1, 0, 1, this is an evil, 4 bits. Okay. Then we have the byte. Okay. The byte is 8 bits. I'm going to give you an example. 0, 1, 0, 1, 0, 0, 0, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. Let me delete the last one. This is a byte, 8 bits. Okay. Now we have something that is called kibibyte. The kibibyte is the same that saying kilobyte. Okay? But why kibibyte? Because we are using the measure expressed in binary. That is the reason that is called kibibyte. Then we have the mebibyte. The mebibyte is the same that megabyte. GB byte, gigabyte. JB byte, terabyte. BB byte, petabyte. XB byte, I don't remember it. Okay? But that is not a question that you are going to have in the IGCSE exam. But I told you that I'm going to explain you how to start doing conversions. Okay, for example, every single exercise that you are going to have, for example, this one in which we are calculating the file size in an image, everything that you are going to calculate, or that means all the numbers that you are going to use, for example, let me use this 1024 times 900, that means that we are using an image like this. Okay, so this is the width and this is the height, and this image is using 24 bits. Okay, so if you want to calculate that image size, you need to do this 1024 times 900 times 24. Okay, this result is going to be given in bits. Okay, I hope this part is clear for you. Now, if you want to if you want to have the information not in bits but in bytes, this one, bytes, you need to use that result and you need to divide it by 8. Why? Because because I get I'm in trouble. Okay, I'm going to explain you why. Because if you have a byte, is the smallest measurement unit in the computer. The next one is nibble. So if you want to pass from bytes to nibble, you need to divide by 4. If you want to pass from bit to bytes, you need to divide by 8. And then now, if you want to uh, pass now, okay, from bytes to kilobytes, you need to divide that answer by 1024. If you want to pass from kilobytes to maybe bytes, you need to divide that answer by 2024. Okay, so let's do an example. Okay, I am going to do it right now. I told you 1024 multiplied by 900 multiplied by 24. What is the result of this? So I'm going to use the calculator and let's do it. 1024 multiplied by 900 multiplied by 24. That means that we have 22 millions 118,400 bits. So I want to express this in bytes. So I am going to take the same number, 22, and I'm going to divide it by 8. That means this, divided by 8. So now we have 2,764,800 bytes. Now, if I want to have this information in kilobytes, I need to use this number divided by 1024. Let's do it. 1024. That means that we have this in 2,700 kilobytes. If I want to convert these kilobytes in megabytes, I must take this number divided by 1024 and etc. Okay? So I hope this part of our conversions you can understand. Okay? So here I have the drawing and here you have the slide. Okay? So let's continue right now. We are here. Let's continue here. This is just an example, the same that I already explained using my digital notebook. And here we have more example about how to do this. Okay. But now let's suppose here, I am going to delete this. Let's suppose that you have an exercise in which you have this number. You have 2,700 kilobytes, and the exercise says that you need to express that number in bytes. Okay? So we are going to get back here. No, this one. Where are you? Here. So we have kilobytes. So yes, I use kilobytes. Okay, so that means that now I am going to use this number 2,700. I am going to multiply it by, what do you think? We divide it. Let me use this. Listo. We divide this by 124. So now I am going to use this one. I'm going to delete this once again, and I'm going to write it once again. So 2,700. I'm going to multiply it by 1,024. And that result, I'm going to use the calculator once again. Oh, I close it. Calculator. So I have 2,700, and I'm going to multiply it by 1,024. I multiply it by 1024. So that means that now we have 2,764,800 bytes. If you want to pass those bytes to bits, so you are going to have this number and you are going to multiply it by 8. Okay? So that is the conversion. If you want to go from the small unit to the biggest unit, you need to divide. If you want to go from the greatest unit to the small one, you need to multiply. Okay? So, as you know, if you have any question about this, just let me know it. Okay? So here we have some examples about how to make those conversions. Okay? So, we are talking about that we have a huge file. So let's suppose that we have a file that has, let me write this number. So let's suppose that this is a huge file. So we need to reduce that file size. So for reducing the file size, we are going to use something that is called compression. So we need to compress the files. So there is okay, data compression is essential in computing because it reduces file sizes. okay, making the storage and the transmission more efficient. Okay, so let me explain you making a draw. Have you seen those videos where someone is going to package something in a box, for example, and that person needs to put a lot of things inside that box? So they are going to do something that is compressed. Have you seen Wally? That is compressed, that you are going to take a lot of things and you are going to put it just in once, and the size is going to be reduced. Okay, so what is the advantage of this? That you are going to save storage space. You are going to reduce the bandwidth uses. For example, if you are going to send a video using your email and your video is so big, so you need to compress it. Just for what? Just for storing the video in your email, and just for the video transmission is going to be faster. Okay, so if you transmit faster, the bandwidth that you are going to use is going to be small. Okay, and look at this one that says improves performance, faster load times for website. So let's suppose that you are creating a website and you are going to make a website about making up things, and you are going to take pictures of all your products. So if you put your original photos, that photos are going to be bigger, and when you are going to load up images in your web page, the web page is going to load slow. So you need to compress your images just for have a faster load images. Okay, and if you are using, for example, I don't know, Teams, and you need to upload an activity, so if your activity is so big, the times for uploading of the times that Teams is going to use for accessing to those files is going to be longer. So if you compress the files, the access to that file is going to be faster. Okay. Okay, now we have two kinds of compressions. So we have loosey compression and lossless compression. What is the difference? So loosey use an algorithm. The only thing that is going to be is taking out some parts of your files. So let's suppose that this is an image, tin, 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 and this is an image of great quality, let's suppose. And you are going to zip, or you are going to compress that file using loosey compression. So when you send that file to any of your classmates, they are going to have an image like this. Why? Because the Lucy makes that the quality of your image, the quality of your audio, or the quality of your video is going to be downgraded. So that means that the quality is going to be poor. Okay? So that is Lucy compression. Now, okay, I already explained this. Now we have lossless compression. Lossless compression is obviously it's going to do the same. It's going to reduce your image size, but when the picture is downloaded for your classmates, you are going to have the same quality. Okay? Lossless means that you are going to lose just a few quality of your image. So the quality, if you have quality loss, is going to be just the smallest. But in the major of cases, you are not going to have loose quality. Okay, so um, The only uh, disadvantage that you have using this lossless compression, that is the compressing of the compression of the file. So the file size, I'm going to give you an example, just using numbers. Let's suppose that this file size is about 8 megabytes, megabytes, and you compress the file. When you compress the file, you are going to have just 7.9 megabytes. You are going to say, but it doesn't reduce nothing. Yes, that is the reason that is lossless compression. Because the purpose of lossless compression is that you don't lose quality in your files. Okay, let's continue. Now, understanding how files are compressed using lossy and lossless compression. Okay, so as I told you, the compression is just algorithms. Okay, so in the slides you have one method uses use it to compress in lossless compression. So lossless compression reduces file size without losing any data. Okay, when you decompress the original file can be restored exactly. Okay, and is used for document, text, and some images. Okay, so let's see this method. This method is called run length encoding. What that means? That if you have a repeated pattern in your files that you are sending, the algorithm is not going to delete the repeated things, but is going to be hidden. For example, look at this example. I'm going to write it on the right part of of your screen. So the original file has a a a a a 1 2 3 4 5 6 7. Then it's going to have b b c. Okay. When you compress the file, we are going to have something like this: 7a, 3b, c. What that means? That we have 7a's. Look at 1 2 3 4 5 6 7. We have 3b's: 1 2 3, and 1c. This is the compressed file, and this is the original file. Okay, that is this method that is called run length encoding, RLE. Okay, Huffman cutting. Okay, this is the method that is used in text compression, just for text compression. Okay, in this one uses shorter binary codes for common characters and longer codes for less common ones. Okay, so what that means? Pretty similar to the previous one. Okay, pretty similar to the previous one, but obviously is not the same. But in this part, I know that you are not going to be asked about this. Okay, and the other method is called Lempel Ziv Wells, that is used in images like GIF, TIFF, and zip files. Okay, the previous one is used in zip files and in PNG images. Okay, and the same is just for find repeated patterns and replace them with shorter representation. So, as a summary, the lossless compression, the algorithm just look for repeated patterns and replace those repeated patterns using an algorithm and The only thing that is going to do is when you are going to decompress, the repeated patterns are restored. So you have the original file. Okay? And try to be so clear for you guys. Loosey compressions reduces the file size but permanently removing some data. So, for example, as I told you with this example, you have your picture. In this picture, you have this is the original image. Okay. When you compress the file using loosey compression, I'm doing the same, and it's not the same. You are going to have something like this. And let's suppose that this drawing loses the half of the face and the half of the body. That is loosey compression. And that is used for GPAG images, for MPT audios, and for MP4 videos. Okay? So, lossless, you don't lose quality. Loosey, you lose a lot of quality in the files that you are sending. That is just the summary, and that is just what you need to know about this. So look at the comparison. Lossless, data loss, lossless, no loss, loosey, yes, information is removed. File size, lossless is larger, loosey, smaller. Reversibility, that means that you are going to restore the original file. In lossless, you can restore the file. In loosey, you cannot restore the file. Lossless is the best use is in text, in documents, and in technical images like PNG and another ones. In loosey is better for normal photos, GPIG photos, for music and videos. Okay? Okie dokie. I really don't know how long this video it's been. Oh, almost 1 hour. And I'm done with this video. Guys, I really hope that you understand this. If not, let me know it. And it's going to be my pleasure to explain this again. Okay? So, guys, thank you. And let's see you in another video and in class, obviously.